Hey guys, welcome to Monday morning. We are maybe afternoon. I don't really know when you're logging on actually. All right, so we're going to try something new. Today you're going to be practicing all three strategies for solving systems. So the first strategy we learned was graphing. Second one was substitution, and the third one is elimination. So we're going to be practicing all three of them. I'm going to give you some examples in this activity that you'll be working on. What you're seeing right now on your screen is called Jamboard. It's just another like Google product, like a Google Slide, Google Doc, that kind of thing. So if you look at your screen, it says, like, here's the symbol for Jamboard up at the top. You see the title up here. What's nice about Jamboard is it has drawing tools. So if I were to click this pen option over here, it gives me different kind of like a marker tip or a highlighter or a brush. It gives me different colors. It gives me an eraser tool. Just a normal mouse selector to click on things. If I want to add sticky notes, I can add sticky notes. I can also insert a picture if I want to insert a picture. My computer's going to take forever now. You can circle something if you need to circle something. Just draw a little circle somewhere. You can create a text box. And then there's this little laser tool, which I guess is just good for pointing things out. Pretty cool. So I'm going to have you guys use Jamboard today and use these drawing tools so you can kind of play around with it a little bit. I even provided a nice coloring activity for you to try out those drawing tools. So you might have to kind of improvise on the colors that they give you, but you can figure it out. At the top, it's kind of like Google Slides where it has like different slides to flip through. So you can kind of view a lot of them at one time, or if you condense that, you can just kind of go slide by slide. So that's the way you kind of navigate through here. So here it tells you the directions. Make sure you're reading them. If I go to the next frame, so obviously this just kind of told you like what the coloring directions were for this activity. I'm going to do one from each strategy. So I'm going to do one graphing. I'm going to do one substitution and one elimination. So for the graphing one, I'm going to do number 2. Since the graph is kind of small right now, I'm going to see if I can zoom in. Let me try it. I haven't really tried it yet. Or maybe I just make this a little bit bigger. That might work too. Oh, wrong way. Okay, so when I go to graph, again, I'm focusing on number 2. If you sometimes see just the ceiling tiles, that's probably because I just put my Chromebook flat and it's easier for me to write that way. So don't be alarmed if you're just like staring at the ceiling lights in this little corner down here. So I'm going to do that now. So see ya. All right, looking at number 2. Oh, you get a weird angle of me now. So number 2, when I'm going to graph, again, I'm using that drawing tool. I'm going to use red here. I am going to graph the first equation. It's already in slope-intercept form. That's easiest to graph. So I'm going to start at -2 on my y-intercept. Put my point there. And then I'm going to go with my slope, which is a -1/1. So I'm going down 1 to the right 1. Down 1 to the right 1. And so forth. So keep in mind, the more points that you actually put on your graph, the better off you're going to be because your line is going to be more accurate and you're going to be able to tell where it intersects, if it intersects, okay? All right, so now it's telling you, so I'm going to go ahead and draw my best line through there. And now I'm going to graph the next equation. So this one I know is a special case. It's either going to be a horizontal or a vertical line. So I have x and y. I'm going to make the xy chart. Right now it's telling me y always has to be -4. So I'm going to just put 3 points down, and I'm going to choose 0, 1, and 2. All right, so 0, -4. So not moving left or right, going down 4, 1, 2, 3, 4. I'm gonna use a different color. Let's go here. And then 1, 4, which would be here, right next to it. It's kind of hard to graph. I need to make the graphs bigger. I'll take that into consideration next time. And then 2, -4. Okay, so I can actually see the point of intersection right now. Okay, so once I have that line drawn, it looks like we have a point at 2, -4 as my ordered pair. So keep in mind, we always want to check. So now that I know what my x value is and what my y value is, granted that I graphed everything correctly and accurately, I can go ahead and substitute both the x and the y value in to both of my original equations to double check that. So this is one of those important steps to not forget, okay? Because it's really easy to make mistakes. So if I substitute that in, if I say, okay, x, that's saying -x, which is 2, minus 2, does that equal y, which is -4? Well, yeah, -2 minus 2 is going to be -4. So that one works out. And then y equals -4. Well, it told you that. So -4 does equal -4. So yes, this is in fact the ordered pair for this one. All right, I'm going to move on to substitution. And I'm doing, what number did I say I was doing? Number 6. All right, so again, with this one, I'm actually going to get that a little bit into the screen a little bit more. All right, so substitution. Keep in mind that's where I substitute in a value in order to solve for x and for y. So right now, as I look at these two equations, one of them's already solved for y, so that helps me out. So once I have it solved for either x or y, I can start substituting. So I know that y is equal to this quantity here, the x minus 8. So I can substitute that in for the y value in my other equation. So I have 2x minus 2 times the quantity, x minus 8 equals 16. Now I can go ahead and solve. Now that I just have x's in my equation, I can go ahead and distribute and solve from there. So I have 2x, and then if I distribute, I have a -2x. The -2 times -8 is going to give me a positive 16 equals 16. I'm going to combine like terms on my left-hand side. Well, 2x minus 2x is going to be, well, nothing. That's going to cancel out, leaving me with 16 equals 16. So at this point, I have to decide, all right, does 16 actually equal 16? Yeah, it's true. So I know that this is going to be infinitely many solutions. Okay, so it doesn't matter what the x and y values are as long as it's basically just two lines that are on top of each other, which means every single point on that line, the x and y values are going to be identical because they're basically the same line. Okay, so that means there's infinitely many solutions because since they're sitting on top of each other, they intersect at every single point on the line. Okay, so that is a substitution equation. Keep in mind, if it weren't infinitely many solutions and I actually solved for x, I would have to use that x value to substitute back in one of my originals to solve for y again, okay? So keep in mind those kinds of strategies. You can always look back at the Google Classroom videos or look back at your book for different examples with these as well, okay? And then the last one I'm going to do is number 12, which is practicing some elimination. Let me find it real quick. And number 12. All right. So we have two equations. My goal with elimination is to eliminate one of my variables, so either x or y. So in this case, I'm going to look at my x values. Well, I have -7 and 7x here. I have +5 and -5y, so it really doesn't matter which one. I'm going to just go ahead and go with the x's since they're right out in front. So if I were to wanting to eliminate negative 7x and 7x, I'm going to add this entire second equation. That way those x values eliminate. So negative 7 plus that positive 7 gives me nothing. Okay, then I'm going to move on. 5y plus negative 5y. Ooh, that eliminates 2. So I have 0 over here equals, well, negative 23 plus 14 is going to be negative 9. Ooh, okay, so does 0, in fact, actually equal negative 9? No, it doesn't. So in this case, it's not infinitely many. It's not one solution. It's going to be a no solution, okay? So this one's just not possible. If I were to, if it weren't a no solution situation and I eliminated my term, I would do kind of the same thing. Once it's eliminated and I get my x or y value, I use that value to find the other one, okay? Just like I would with that substitution. If you need more examples or if you have questions about these different problems, there are going to be a mixture of no solution, infinitely many, and one solution with that ordered pair. If you have any questions, make sure that you're reaching out and communicating with me. I am telling you right now that you are going to have a quiz. Yes, a quiz on Tuesday over this, okay? So today is definitely the day that you want to make sure that you are getting your questions answered, okay? All right, good luck. You guys got this.